Hello, we're going to go over part 2 of 1.6, solving other types of equations. All of these equations will have radicals, and I'm only going to limit my examples to square roots, but you can use these same ideas, these same processes with any root, third roots, fourth roots, fifth roots, etc. What you need to do first is isolate the radical so that we can square both sides to get rid of the radical. Or if you had a cubed root, you would isolate the radical so that you could cube both sides to get rid of the radical. If you have more than one radical, you'll have to repeat steps 1 and 2. Once you get rid of the radical, you just solve your equation and then look for extraneous solutions. So the first thing I'm going to do is add that square root part and get the square root of 3x plus 18 on one side and x on the other. Now I'm going to square both sides. When I square both sides, I'll end up getting x squared equals 3x plus 18. That looks like a quadratic, so I should subtract 3x and subtract 18. So now I have the quadratic equation x squared minus 3x minus 18 equals 0. Now that factors. That factors into a minus 6 here and a plus 3 here. And now when I solve that, I get x equals 6 and x equals negative 3. Now, because we started off with a first degree equation, x to the first power, but we turned it into an x squared equation, a second degree equation, that gives me 2 answers, but my original problem should only have 1. So we need to check our answers. So let's check the number 6 by replacing all the x's with 6. Is this a true statement? Is 6 minus the square root of 36 equal to 0? Yes, it is. Is negative 3 minus the square root of 3 times negative 3 plus 18 equal to 0? Well, when we look at these square roots here, we're talking about the principal square roots only. So I do have the square root of 9, but negative 3 minus 3 does not equal 0. So the solution is x equals 6. Let's look at another example. I've got two radicals here, so I'm going to have to do the repeat if necessary step. Now, it's up to you which radical you want to get by itself. However, I think you would find getting the longer radical isolated is the way to go. So I'm going to subtract the 2 and add the square root of x minus 12, and now I'm going to square both sides. Now, when I square both sides, the square root of x minus 12 squared, that's easy. But here I have to multiply this out. I have to do the distributing, the foiling, if you had some teachers that used that term. So I get the square root of x times the square root of x, or x, minus 2 times the square root of x, minus 2 times the square root of x again, plus 4. Now these are like terms, so I have x minus 4 square root of x plus 4 equals x minus 12. Now I'm ready to repeat if necessary. We want to isolate this square root of x. So we do what we need to do, subtract the x, subtract the 4, and now we're going to divide by negative 4 because I truly need that to be isolated. And I get the square root of x equals 4. I square both sides, and x equals 16. Now check our answer. We're going to replace x in the original equation to see if it really does equal 2. Well, the square root of 16 is 4. 16 minus 12 is 4. Does 4 minus 2 really equal 2? Yes, it does. So x really does equal 16.